So we understood that within transformers, one of its key differentiator is actually the concept of attention. Now, in addition to this, there are a few more concepts that we have to understand before starting or training LLMs. And the first one is what are tokenizers, and then we'll also look at embeddings, and we'll also look at different types of decoding techniques as well. And these three concepts will give us a bit more grounding in what transformers are and how LLMs and the modern LLM can be fine-tuned and used effectively. So one of the things with transformers is they can only work with numerical values like many of the data science and machine learning models out there. So to convert all these words into a numerical value, that process is known as tokenizing. And tokenizers map text to numerical values, and it's as simple as that sounds. So we're just converting these words into numericals, and they are known as tokenizers. So here is a blog post which explains a bit more about how these tokenizers work. And as you can see, when a sentence is provided, it just outputs a number, and there is no context or learning happening yet. It's just purely converting from word to numericals. And you can read through this and see how the modern GPTs and llamas and the palm models are working. Now, there are a few types of tokenizers as well. So there is word and subword and character based, etc. But few are very, very famous and are worth noting. So if you were to think about just word based tokenizers, this means you give it an entire word and each word gets a number assigned to it. So let's say, for example, dog is number 15, and maybe dogs with an S at the end is number 16. So you can see this can go out of hand really, really quickly, especially if the text or the language has very large vocabulary. And if each one of these are getting a different number, then the word-based tokenizer will be really, really huge. So to counter this, there are two more variants. So there is character-based, and it can accommodate large vocabulary, but the token carry less information. Instead of converting the entire word into a number, we convert each character into a number. And as it says here, it carry very low amount of information when it comes to embeddings and understanding the context within the sentence. So middle ground is using subwords, which is mostly used by all the LLMs today, which is you take a word and then split that into two different, or how many ever different smaller chunks you can split that into. And one thing to keep in mind here is we don't want to split a word which is frequently used. So most of the rare words can be decomposed into smaller, meaningful subwords. So that is why you see often in the documentation which says tokens are actually not words, and they are, at least in GPT's case, they are all subwords. And there are various techniques of achieving all this. There is byte pair encoding, which assumes spaces to be separate words. And there is also sentence piece, which takes inputs and raw outputs and applies all these unigrams, and BPE, which is byte pair encoding and such. So there is also Hugging Face library, which you can use to import all these transformers and run some tokenization yourself. So you can import transformers from BERT tokenizer and give it an input, and it will create a token for you. So this is based on the BERT tokenizer, and there is also Excel net tokenizer as well, and you can give it an input and see what kind of outputs you're getting.